Hello, everyone. Welcome to our third seminar. So we are here to know a little bit more about others people research and share the ideas, discuss. So feel free to actually nominate yourself or other people for the next sessions. So we are gonna have two presentations today. We will start with the role of non-methane hydrocarbons in ozone formation with Mahendra from the Aryabhata Research Institute of Observational Sciences from India. And he's gonna talk with us a little bit about this topic, and then we're gonna have some time for questions. Also, feel free to type in the chat questions if you have something or if you would like to discuss something. And then right after, we are gonna have like a second presentation by Connor about ozone depletion from satellite megaconstellation emissions. Just a reminder, this recording is going to be available in two parts in our website. So if you go into website, you're going to see the recordings of all of our past events. But as we're going to see some very new unpublished data today, we are going to wait a little bit to make it available for in our website. So in case you see later, just this reminder. Mahendra, the floor is yours. Welcome, and thanks for the availability.
Thank you. I think I'm clear and loud. So today I'm going to talk about the role of non-methane hydrocarbons in ozone formation processes. So I'm from the Aryabhata Research Observational Sciences Series Nainital, and I'm very much thankful to the organizers to provide me the platform to discuss about my work related to this. So let's start with the little bit introduction. These two pictures basically describe my work. Basically, I'm working on the air pollution part. So left side picture is showing is the polluted days when you have the haziness, smoke in the atmosphere, whereas the normal day it quite is observed during the rain, day after the rainfall or clear day, we can say. So if we talk about this pollution, so almost 4.5 billion premature deaths were observed due to this air pollution, and I think it's three most cause for the numbers. And if you look at this is the aerial distribution, spatial distribution of the molarity due to the air pollution, and you can see the highest mortality rate is basically due to the air pollution over the southern Asian region, and 90% of these is in the developing country. So this South Asian region is also a group of means if you consider the India, it is also a very much developing nation. So if you talk about in terms of the ozone, there is almost 0.3 to 1.3 million deaths per year. That's why we are focusing on this topic. And if we talk about the ozone in the troposphere, which also known as the surface ozone, this is basically a secondary air pollutant. It's formed due to the photochemically processes in the lower atmosphere, and it also acts like a greenhouse gas. So if you see the different processes of ozones in the troposphere, it can be brought down to the downward to the from the stratosphere to the troposphere. It can be formed due to the photochemically buildup because of the non-methane hydrocarbons, carbon monoxides, in the presence of nitrogen dioxide, which is basically tells about the chemical production of these surface ozone. And basically, we are focusing on this details. And this ozone is itself is a precursor for the hydroxylic radical, which also known as the detergent of the atmosphere, because it is converted all the primary pollutants into the different species, transform into different species. And if you talk about the human health aspect and the crop productivity, it also affects or have the adverse effects on their on human health and the crop productivity. So basically, during this talk, I will cover about the non-methane hydrocarbon, which is one of the important precursor for non-methane hydrocarbon, and see how its role is affects their production. So next, if you think about the non-methane hydrocarbons, so basically these are the subclasses of volatile organic compounds. Okay. Volatile organic compounds, they are the primary pollutants, means they are emitted directly emitted from their sources. Their sources varies from the natural sources from ocean to vegetation, and in category of the anthropogenic sources, vehicular exhaust, biomass burning, industries, solvent uses. There are so many anthropogenic sources of them. So if you see the role of non-methane hydrocarbon, it is very much client to the ozone formation in the troposphere. It can also has an important role in the aerosol formation, secondary organic aerosol formation, and you also have the some of the non-methane hydrocarbon species also has the some health risk impacts also. So basically, here we are talking about their important role of the surface ozone precursors, and they are also important precursors for the secondary organic aerosols. So if you see the chemically process, the chemical process which is more important and which is more basic, we need a one atomic oxygen in the atmosphere to produce the ozone molecule in any atmosphere. So in the ambient atmosphere, what happens when we have the non-methane hydrocarbons? So it's governs the in the presence of the OH radical, it can transform into HO2 or RO2, and then there are two different pathway, which is the one is this very simple or the normal pathway for the other precursors to carbon monoxide, methane also. But in the second pathway, you have find there is a non-methane hydrocarbon because have the n numbers of the carbon atoms, then it can convert one non-methane hydrocarbon into the NO3, means n numbers of the ozone molecules, and it also produces a byproduct of the carboxylic radicals, sorry, carboxylic compounds, example the aldehydes also. So if you see the impact of their in the ozone formation, this is a simulation based study, and you can see without non-methane hydrocarbon, ozone production is not that much good. However, in case of the if we have the non-methane hydrocarbon in our model of the simulation, the production is quite high, which also tells is the right side isoplate diagram. So if you can see in the atmosphere when we have the low number of the VOCs emissions, there is the production rate. These lines, these curves represent the production rate, so that's not that much high. But as you go to the higher atmosphere, so you can see with combination of the NOx and VOCs, we have very high number of the ozone productions. So we can say that ozone formation potential is a very high of the non-methane hydrocarbons compared to the other precursors. And in the next, it looks very simple that non-methane hydrocarbon has a very high production. However, if you see the isoplate diagram for the different region, you can see the different region has the different ozone formation potential, and these lines, the lines which reflect the ozone formation production rate, these are the not that much linear. They are the non-linear in the shape, and you can see they are shifting from the rural to the urban atmosphere is quite very high. And if you go to the remote atmosphere and if you go to the marine also, so you get different kind of the feelings that different atmosphere have the different ozone formation processes, they have the different rules. So it's better to have the continuous observations of the ozone precursors with their with ozone observations. So if you see in terms of the non-methane hydrocarbons and ozone observations from the Indian perspective, there are very few sites where we have the simultaneous observations of these uh, precursors and ozone, and very much is very much absent from this Himalayan region, Indian Himalayan region, we can say. So we have started their network in this Himalayan region. This is, you can see the satellite topographic map of the Himalayas. There is a high greater Himalaya. You can see the snow covering mountains, and these are the some. This is the mountainside Nainital. There is Nainital, and these are the IGP site. You know very well that the IGP site is the most polluted region in this over the globe. And this is the pictorial view. You can see this is a high altitude Himalayan mountainside, and these backgrounds represent the IGP site, very much populated area. And these are the some details about how we can collect the samples. And we also start a similar kind of observations at the foothills of the Himalaya. The foothills of the Himalaya means the region between the IGP regions and the Himalayan regions, to show how their chemistry is behaving at that region. And these are the some important observations from the non-methane hydrocarbons from the mountain side. So you can see that there is the daytime buildup as compared to their levels in the night time. They are quite high. And this is just opposite to the urban behavior, urban sites, because in the urban sites we have the morning time peak, but here we couldn't find any such kind of the behavior. And these are the very important observations from the South of Asian perspective. And apart from this, if you see the monthly variation there, so they have the higher levels in the spring times, and due to the monsoon, they have lower level in the monsoon because of their scavenging due to the dilution due to the rainfall. And if you see, there is these are some representative species. So some of the species even do not show such kind strong variability in terms of their mixing ratio. So if you out of this ethane was the most dominant species, whereas the propylene and ibutane are the least abundant species for that. And if you we also try to fabricate their sources. So the biomass burning and the LPG emissions are the more important and the important processes over this site. And once we compare their results with this the IGP site, so you can see the red bars are showing their mixing ratio at the IGP site, whereas the black bars are showing uh, their mixing ratios at the mountain side. And this scattered plots are showing the day and night time values, where so you can see in the mountain side we have the daytime high values, whereas in the IGP region or IGP side we have the nighttime high values. So we can see you can see the different processes at the at mountainous side. And if you saw the percentage contribution of these non-methane hydrocarbons over the two sites compared, so we have found that ethane has the most dominant role, whereas in the at the mountain side, whereas the propane, which at the has the most dominant role at the IGP region. So LPG emissions are the quite means leakage emissions are the quite dominated at both the side we have seen. And if we talk about the variation of ozones in the foothill areas, so we have getting this kind of behavior throughout the seasons, in the different seasons. And this is showing the daytime highway buildup. Because of this, we can and the nighttime lower levels in the nighttime, and this shows the photochemically production of ozone due to their precursors, carbon monoxide, NOx, and non-methane hydrocarbons. And by their rate of change, it's also show the production and their loss processes. These results we utilize in next coming areas, where we see the high non-methane hydrocarbons, level of the non-methane hydrocarbons have their roles in this ozone formation. So this also shows the Himalayan foothills are behaving like the urban sites. And one more thing, if you see the labels, nighttime labels of the different sites, Delhi, Pantnagar, and Dehradun, the Dehradun labels are quite higher as compared to the other side, which which can say the night time, because of an NO, the night NO, the low level of the NO at the Dehradun side, which is less polluted as compared to the other side, but the levels, the variation is so their urban behavior. So if you see the seasonal perspective, the complete seasonal picture of this site, so springtime high values we observe, and monsoon time low values, and we the springtime also they have processed the national air quality limits of the 1 hour standard and 8 hours standard also. So which is more implicated to the health impact also. So the once we try to segregate how the spring times is behaving, so role of the biomass burning is quite. We have seen the role their role since the on the ozone process in ozone levels. So you can see the 94% is a trajectory originating from the highly fired regions or biomass burning regions. So we can say during the passage of the time when the air travel from that area, it get good numbers of the precursors under the strong solar radiation. Uh, converted or transformed into the good number of ozone molecules. And if you see the time series plots, so it also reflects their, although the data is not that much continuous, but although it's reflect their roles in the increment in the ozone numbers as we go with the time of fire. And these are the numbers we are getting when we segregated their study. Almost 50% of the increment in 2016, which is well literaturized by the means people who are published. That 2016 is a quite good, getting good, got good numbers of the biomass events. And to segregate their non-methane hydrocarbon routes, we also try to utilize the box model to formulate how the behavior, ozone behavior is changing. So these are the, you can see the simulations of the ozone ozone labels at the Dehradun. The red color is a model and black color is the observations. We increases our to test the NOx sensitivity as well as their hydrocarbon sensitivity. We changes their labels, and what we see there the very much increment, large enhancement in their values during the daytime for the variation is NOx, and very minor increment in their values due to the variation of their non-methane hydrocarbons. So this, we can say the NOx play prominent role in controlling the ozone levels at the foothills as compared to the non-methane hydrocarbons. And we also try to find this ozone sensitivity study with the satellite and the CAMS reanalysis model data. What we found that the both the showing the same results in some season, but during the some seasons when July, August, September, there is the OMI satellite is showing something NOx limited regimes when, however, the CAMS model is reside within the transition region of the ozone sensitivity. In the next, we also try to segregate how much number of the ozone produced during the daytime. We simulated this and found that the 48.4 ppbs of ozone is produced during the daytime, and out of which we also see 7.4 ppb of ozone due to the loss. This the black color plots showing the loss processes, and the red color is showing means gain processes, and the blue color, the green color is showing the resultant ozone production. So it all came to the 40.9 ppbs. And when we observe utilizing the observations and the model results, we have found there is this difference of the 11.1 ppbs, which we can say due to the dynamic processes and other processes which are also playing the roles at the formation of means at the ozone levels at the foothill sites. We also segregate the role of the different processes. So you can see the HO2 plus NO, which is a primary processes, is playing the much significant role. Whereas if you see in the production processes, wherein if you see the loss processes, we have the direction of the ozone with the HO. So, if you see the means ozone formation potential of the non-methane hydrocarbons, we applied the different species combination as a box model and see which species are governing more ozone formation. So you can see that the aromatics have the very much larger role and very much high ozone production rates as compared to the alkyne species. And if you see, these are the observationally results. So aromatics has a much more uh, have the ozone production percentage contribution towards the ozone production observationally. So these two results are quite inclined in similar direction that the aromatics play important role in the ozone formation processes. Apart from that, we also started involved in the mobile laboratory campaigns. So we have utilized these mobile laboratories to segregate the spatial distribution. Right now, up to here, we are discussing about the only one station data. Now, if you see where we have the good mobile laboratory, so we have good number of the coverage in terms of the area as well as the sites also in terms of the space and time also, spatial temporal variations. So these are the some initial results. So you can see the distribution of the temperature, and these are the ozone distributions. And you can see there is a Nainital station. These are the Devasal, which is quite higher at the higher altitude, and these are the some mobile roadside campaigns ozone level during the foggy day and normal days. You can see quite different behavior. If you see, one is the interesting thing is this plot. If you see in the foggy day, there is a much depletion of the ozone. However, if you see the roadside ozone in the normal days, it is quite means higher as compared to the means is comparable with the Nainital and Devasal site. So we can see there is NOx level, quite high NOx level during the foggy days at the Himalayan foothills, which also implies the in the same inclination with the results as the earlier study I presented. So, and these are the some and these are the some hydrocarbon species we have samples we have collected roadside from the Gurugram, Sonipat, Delhi NCR region to Himalayan foothills. So in this result also it's quite surprising that we have good number of the non-methane hydrocarbon at the foothills as compared to the intermediate sites, whereas the Delhi NCR, which acts like a source region, have the values. Uh, higher values. And in the role, if you reflected these numbers, non-methane hydrocarbons number into the ozone formation potentials, and so you can see there the role is very clear that the sites which are very close to the Delhi NCR has more prone to the ozone formation processes as compared to the intermediate site. And similar, we have also have the good numbers in the foothills also. So thank you so much for the, I want to acknowledge the director Aries and Aries team for this all the results. And thank you so much. Floor is.
Thank you very much for your presentation, Mahendra. Those are very interesting results. Before opening for questions, I have one curiosity. What is the altitude difference between the sampling sites? Like when you say the foothill of the mountain, are we saying kind of this a similar altitude as the city, the urban region? Is this kind
Yeah.
of similar, or is it already like a little bit, higher and so?
Yes. So if we talk up in terms of the altitude of the foothills, it's
Mm-hmm.
almost 700 meters above from the mean sea levels. Whereas if we talk about these, wait, just if we talk about these Delhi NCR sites, they are about 300 meters above from these sea levels, because we are going to the higher levels. So the altitude is means slightly increasing as we go to the Himalaya.
Okay, thank you. Questions?
There are two in the chat. We can probably start with those. There's one from Shahid stating, we know that winter is the highest polluted season in the IGP. However, we can see from the figures that ozone production is higher in spring than winter. Is it because of the biomass burning that happens in the northern part of India?
Okay. So results I am showing here. If we talk about in terms of the ozones, basically it is the foothill sites. So they is just away from the what we can say the vicinity of the source region. However, they are means they are we observe their they have the good numbers of the springtime biomass burning. Yeah, we also showing the same thing and other processes. Even in case of the ozone, if you see, we need a good amount of the solar radiation to the formation of photochemical ozone. So in the winters, we do not have experience such kind of the solar radiations because of the fog and clouds also. So we can say the levels are quite high in the northern region because of the biomass burning plus the what we can say the intensity of the solar radiation during that time.
Okay. And following up on that, I think in the next slide, you were showing some box model
Yes,
simulation results.
yes.
Was it for a specific time in the year?
Yes, because these no, yes, these are the for the specific time of the year for the spring season, because then we have observed the good amount of ozone, means we have seen the clear sky and all these kind of these conditions. So we applied for the springtime.
And the plot on the left is showing that the ozone levels are very different with respect to the NOx concentration.
Yes,
So it looks
yes,
like you can
yes,
identify a threshold in somewhere in between.
yes, right.
Okay. There's another question from Sachin. We see that ethane is dominant in the mountain region while butane is dominant in the urban areas.
Yes.
Is there any difference in the source of both of these NMVOCs, or they are sharing common sources?
So in case of the ethane, if you see in terms of their lifetime, first of all, because the mountain side is just away from that, not away from the local sources, the ethane the lifetime is quite high. So it can be traveled from the other regions too. So it is reside in this the area, the mountain region or the Himalaya. So the and but however, in case of the butane species, the lifetime is not that much high. Lifetime is very much short. So we can see during the transportation, they can be transformed into they can be transformed into the other species. And source wise, the ethane has the much the contributed from the fossil fuel immersion and compression processes. Whereas if you see in case of the butanes, it is basically from the LPG and natural gas emissions.
Okay, so in principle, like mostly fossil fuels is different exact fossil fuels.
Yes.
Or diesel. Okay. Any other questions for our speakers?
Go on, I have one.
Emily?
So I think your results were showing that was the LPG fuels were important, like precursors for ozone. And am I right in saying the sort of uptake of these, I guess, like cleaner fuels for like cooking has been increasing in India, sort of like I guess over the recent, maybe like past decade or past 5 years. Does that translate into you seeing ozone increasing in these regions that have high emissions from these LPG fuels? Like, is ozone increasing as well in these regions, or is there something else controlling like the regional ozone concentrations, like over like a longer time period?
Okay, so it is, if we talk about in terms of the LPG emission, they are means quite well known. They are the good sources of these hydrocarbons. Even the all the IGP sites having, if you see the all studies of, across all the IGP sites, we found that the LPGs are one of the major contributor for the non-methane hydrocarbons. So whenever we think, but they are replicate in terms of the ozone formations. So in our results, they are showing the aromatics, which is means more from the anthropogen means the solvent and industries also. So these kind of the results is, I mean, so when we reflect these emissions in LPG emissions into our pictures of ozone formation, it's not that much good in numbers, means dominant kind of things. Yeah, but they share some numbers, but not in the dominant role.
Okay, in the interest of time, let's move to Connor's presentation. Mahinda, there's one more question from Nazrul, if you can answer in the chat.
Okay, okay, thank you. So should I?
In case you have more questions, just ask in the chat, and then we are going to make sure